Okay.
Okay. Hi.
All right, hi.
Okay,
Hey.
we've zeroed it out. We're about to put some aluminum in. Trying to get up to about a gram. Balls here. It's taking far too long. Well, we're there will be some impurities. That's why we've got the filtration coming up next. So
You gotta speak louder.
We're aware that there will be some impurities, so that's why we have the filtration coming up next, so we can.
Sound like a weatherman.
Alright, we're getting close.
Oh.
Whoa.
Okay. Okay. Let's do this.
What the next step is.
Okay, what's the next step?
That's a great question. Prepare 25 milliliters of 3M KO8. Slowly add 25 milliliters of that in a fume hood, in bold letters. The reaction will be violent in about 3 minutes in length. Keep all flames away. Allow the reaction to proceed until all the foil is dissolved. Record observations in your data table.
Okay, cool. I know, right?
Just why is there a
All right, next step, we'll wait a few minutes.
Okay, and we are filming. So you're wasting film. Want to tell our viewers what you're doing?
I'm pouring the potassium hydroxide into the thing, and hopefully I can get it right. So.
Okay, pour the potassium hydroxide into the thing, and do it right. Oh,
The graduated cylinder.
yes, the 50 milliliter graduated cylinder.
Careful, we'll only get one shot of this one.
No pressure.
Thanks, guys.
I'm gonna come around this side over here.
It has to be 25, give or take. Alright, whatever.
Alright. Sorry. Oopsies! I have it underneath my foot. I got it. It's underneath my foot.
Yeah.
this was our solution that we have right now. And we're setting up our vacuum.
Pouring our stuff in there.
Yeah, make sure everything gets in there.
Okay.
Alright.
It's gonna be like.
That looks like
Yeah,
oil.
it's so good. Yeah, it does.
Alright, that's gonna have to be good.
Somebody has to wash that out.
Alright, so now we're getting all the impurities of the aluminum in the vacuum, and then this is our solution, our clean solution at least.
Looks like water.
Yeah, this looks like water. Now we're disassembling our little vacuum thing, and we just let the solution cool for 5 minutes, so we are gonna go get the sulfate? The sulfuric acid. What are you doing, Jonathan?
Pouring into different beakers so we can actually do this better.
Okay.
Just transferring from one container to another.
Yeah.
Nothing all that interesting.
It's a very important step, but to get it.
Okay. Pour.
Pour the sulfuric acid.
Okay, this is sulfuric acid. This is dangerous.
It's
Don't
very
touch
sulfuric.
it.
And acidic. It doesn't look like it would taste good.
That's cool. What are you doing? It's not warm yet. Alright, we're gonna stir this with a glass stirring stick or rod or whatever you want. Jonathan, move your hand. Okay, don't let it spill though.
Yes, I'm trying very hard.
Got it.
Stir faster. Don't flick it out of the thing though.
Everyone's a critic.
I believe in you, Jonathan.
Thank you very
I
much.
believe in you too, Jonathan. It's okay.
Just hoping I can get this back to being a clear color.
Alright. Still stirring, and now we have the hot plate on.
We're heating gently.
Heating gently.
To be very gentle with the heat.
You're not cooking. So chemistry is actually cooking.
Going the other way now, stirring.
Maybe we should turn up a little more.
Gotta be gentle.
I am, but it's only on like what,
You're
2?
gently turning the heat up.
Alright, I'm gonna leave it right there on 5.
Guess that'll be gentle enough.
I mean, okay, that's half the heat the thing goes up to.
But how hot does this thing get?
That is the question.
This is by far the most boring part. It's definitely more boring than the swan.
It's more boring than what?
The swan.
My swan?
The swan was interesting. This one.
I made an origami swan, that's what he's talking about.
Yeah, we didn't record that stuff.
Yeah, we didn't record that stuff.
My arm's getting tired.
Okay.
It's boiling now. Just trying to get it to 50 milliliters. It is very close.
Yeah, it's getting there. It hasn't been boiling for very long, probably only about a minute or 2.
Yeah, probably 45 seconds or so.
All right.
Looks
Cool.
like it's under it. Do you want to take it off?
The beaker off of the hot plate, kind of letting it cool. It's at 50 milliliters, so I didn't want to let it boil any longer. All right, cool. Yep.
Oh yeah.
Cool. All right, so we're done with boiling it, and guys, we're done with boiling it, and the beaker is now cool. We're gonna put our parafilm and our names on it, and that concludes our experiment for tonight.
Good night.
Good night, everyone.
Merry
Bye.
Christmas, Charlie Brown.
What do we have here?
Delicious alum crystals. And 50 milliliters of ethanol.
Okay.
Pour the or the alum in.
Okay, pour them out for the alum in.
That wasn't much.
You had to put the ethanol in the with the crystal.
Yeah, I'm just saying that wasn't much that came out.
All right, we'll pour the ethanol.
Second
Put
shot.
it down. Put the beaker down. Yeah.
I'm trying to put it at an angle to get stuff off the side.
It's okay, we can just swirl it around.
Okay. We've got the what's it called? Paper.
Don't pour it all in there, because we might need to What are you doing, Jonathan?
I'm trying to get the last bits of this alum out, or so we're told.
How much do we have left in the cup?
One wee bit.
Huh. All right, we got most of the alum back in the filter, and here's the ethanol that has been filtered out. All right, it looks like that all the water, or I mean the ethanol, not water, is in the beaker. Yeah, the water's still in the crystals. Now we gotta, take it out, put it back on the scale, and then we can determine whether this is alum or not. Right now, Jonathan.
I'm measuring the
What?
mass of the alum with the weigh boat and the filter paper.
The hydrated alum, right?
Yeah.
Right.
And we haven't dehydrated it yet. We don't have nearly enough time to do that today, so we're gonna let it dry till next week.
All right.
If it's 19.8 something, we'll figure it out in a minute.